Okay, so then sine squared alpha plus cosine squared alpha equals 1. And from here, given one or the other, we can solve for the one we are interested in. So if we're trying to solve for sine squared, 1 minus cosine squared alpha, and then of course we will take the square root from both sides. But since this is quadratic in sign, I cannot forget to write plus or minus. Identically here, what? Cosine alpha will be?
Plus or minus.
Yes?
Minus
1 minus sine squared alpha. Very good. That's it. Good. So we want to go back to sine 30 degrees, cosine 30 degrees, and so on and so forth. We have not talked about alpha being pi over 6. And then we want to talk about alpha being pi over 3. Now, we do have to remember that since pi is 180, 180 divided by 60, this really represents alpha equals in degrees how much? Yes. Hi, Elizabeth. Yes. You needed it?
Yes, I'm so sorry. Yes, I'm looking at the Russian again and again. I just want to ask, every time we cannot finish it, start over, or we can do the one we
You
need.
have an hour and 20 minutes, but you have 2 hours. You can do it as many times as you want, but you must finish in 2 hours.
It's happens,
Please.
and if we can't finish it, we take it. We have to start all over again. Okay, it's fun. I
Okay.
just want to
Good.
thank you.
You will be able to teach this class after you do this. That's what I want.
Is the 12 dates today? Is today the last day?
No, you have 2 more weeks.
Thank you.
I love you. Okay, I love you too. Thank you. So easy to make a student happy. Just give them 2 more weeks to work on a test. So 180 divided by 6.
30.
Very good. And 180 divided by 3.
60.
Very good. So we do know the 3 most important angles right now, right? And the other one was alpha equals pi over 4. What did we say pi over 4 was? 45.
I'm filling this table.
Yes, yes. I have to build to that. I cannot just give you numbers to fill in. Yes. So we are talking about this. Good. Ready? So we're going to start with 30 degrees. So in a right triangle, here's how I get the 30-degree angle. If you'd like to watch for a second, I divide this into 3 equal parts. You can say they're not equal. I will have to agree. But let's say they are. Of course, it's not perfect, right? So this is my 30 degree. Agreed?
Yeah.
Because it's 90 divided by 3. So this is my alpha 30 degrees. I know that from this point, I draw a vertical line. And I did form a right triangle. This is the right angle. I'm going to take it out because it's too small. So I'm going to say this. And this is my 30 degree or pi over 6. I'm sorry. I should have written pi over 6. Okay. What does this represent? Which is this piece? Sine.
Alpha.
Exactly. Alpha or 30 degrees or pi over 6. Perfect. What is this piece between here and here? Right. And this must be 1. Agreed?
Yes.
Good. What do we know about this triangle? I know that it has an angle of 30 degrees, it has an angle of 90, and then therefore this one must be 60. There is something very special that we know from a long time ago in geometry, from geometry. In a 30, 60, 90 degree right triangle, there is something we know. If we remember, it's okay if we don't remember, I'll tell you. Do we remember something special?
Something about.
Yes?
I know it's something about the sides.
Awesome.
Ratio.
Awesome. Yes, it is. That's true. So here it is. Here is what happens here. The opposite leg of the 30-degree angle equals or measures always, but this is only in the 30, 60, 90. If it's 31, 59, 90, no. Has to be 30, 60, 90. Okay? Measures half of the hypotenuse. So if the side opposite to the 30-degree angle measures half of the hypotenuse, I know sine. How much is sine 30? Forever. That's it.
Not radians, right?
Half of one.
Yes.
Good. So that's the reason why I started with this. I have sine. It's 1/2. I want to determine cosine. All I have to do is plug it in. So 1 minus 1/4 is 3/4. And I have to take the square root. So let's write it first. So then cosine 30 degrees equals, I will not write plus or minus. Why I will not write plus or minus in this particular case? Because it's in the first quadrant, where I know everything is positive. X-axis and Y-axis are positive. So that's the only reason why I will not write plus or minus. So I will write the square root of 1 minus 1/4. Why 1/4? Because I know that sine is 1/2. So then 1/2 squared is 1/4. Correct so far? Okay. So then cosine 30 degrees will be 4 minus 1 is the square root of 3/2. So now let's go back to our chart. Here's our chart. Sorry, I forgot to keep it. So this is my pi/6 right here. Now, if you kept it in the correct order, that's fine. I didn't. If you remember, I messed up. Last time I put some values where they didn't belong, and then I erased it. So pi/6, sine is 1/2, and cosine? Very good. So please put 1/2 here and the square root of 3/2 here. Please determine tangent and give me tangent. How will you determine tangent 30 degrees? What will you have to write? Exactly. So tangent 30 degrees is 1/2 over the square root of 3/2. So you will have 1/2 and 2 over the square root of 3. You will simplify, always simplify before you do anything. And I would write it 1 over the square root of 3, but we have to rationalize it as the square root of 3/3. Now, when I ask you about cotangent 30, look at the one that is not rationalized, because otherwise you have to simplify further. You don't want to simplify further. Just look at the one that is not rationalized. What do we get? That's it. Now, continue with secant. Secant 30 degrees. What will you say about secant 30 degrees? Yes, or flip cosine. So if I flip cosine, I have 2 over the square root of 3, but I have to rationalize it. So it would be 2 the square root of 3/3. And finally, for cosecant, exactly. So you have all these 6 numbers, right, in your table, pertaining to pi/6 or 30 degrees, correct? We do? Everyone? Okay. So now let's go back here. So I'm back to the 30, 60, 90 degree right triangle, correct? Now I'm interested in this angle. Okay, here is it. Here it is. What is its sine? The same with, what was cosine 30? Not 1/2. That's all you have to remember. Not 1/2. The only one that is 1/2 is 30 degrees.
Yeah, right.
So if I say sine of 60 degrees, it cannot be 1/2. It has to be the other one. And the other one is? Right. So now let's go and fill it in a blink. What will you put in the first cell for pi over 3? What will you put in the second cell for pi over 3? 1/2. What will you put in the other one? Reverse the tangent with cotangent.
Yes,
And then the square root of 3 over 3. And then reverse the other two as well. And you're done. So let me write it here for you. Okay, let me write it for everyone. So pi over 6 and pi over 3.
It's on campus.
Sorry, thank you. Sine, cosine, tangent, cotangent, secant, cosecant. Okay? So this is 1/2 the square root of 3 over 2. This is the square root of 3 over 2, 1/2. I don't care about the rest. That's all I want you to remember. I'm sorry, pi over 4 I wanted to add here. If you remember more than this, you're wasting your time because you should use your brain cells for something useful. If you ask me what is cosecant pi over 3, I'll say I have no idea. Cosecant pi over 3 is 1 over sine, so it's 2. If you say find tangent pi over 6, I have no idea. Tangent pi over 6 is 1 over 2 with the square root of 3 over 2. I flip, it's the square root of 3 over 3. Do not waste your time. That's all you need to remember. 1/2, 1/2, the square root of 3 over 3, the square root of 2, the square root of 3 over 2, and this is the only angle whose sine and cosine are the same. So basically, I do ask you to remember 3 numbers. 1/2, the square root of 3 over 2, and the square root of 2 over 2. You don't have to remember anything else. It will take you 30 seconds, 20 seconds to determine any of them knowing these numbers and knowing their definitions. If I don't remember what secant is, then I will not be able to determine it. So I have to remember the secant is 1 over cosine, and once I have cosine, I'll determine secant in a blink. Okay, there is no need for more than that. So then here tangent was the square root of 3 over 2. I'm sorry. And this was the square root of 3, and secant was 2 the square root of 3 over 3, and this is 2. So now here they are reversed. So this is the square root of 3, the square root of 3 over 3, and 2 to the square root of 3 over 3. And of course, this is 1 and 1, the square root of 2, and the square root of 2. However, do not waste your time with these numbers. There's no need. Okay, back to the book.
Can you go back to
Yes.
30, 60, 90, 90?
Yes. To the triangle? Yes. I was going to do just that anyway, because I want to talk about one more thing before we look in the book. Yes.
The opposite leg is half the
Yes, yes. So the opposite leg of the 30-degree angle measures half of the hypotenuse. In this case, since the hypotenuse is 1, then sine is 1/2. Okay? Good. So co-function identities. So I want to go back to what we just discussed, and I'm copying the triangle one more time. And we said that this was 30 degrees. We said that this was 60 degrees, and this is 90 degrees. We know that this is a triangle copied from the unit circle. I just wanted to make it bigger, so I took it out of there. Let me see where I'm at with time. Oh, I'm good. And now we know that this piece for angle 30 equals how much? this piece. Very good, which represents cosine 30. Awesome. And also this piece for angle 30 is very good, or the same thing with sine 30. See why I like my colors. Also the same piece in green represents what for 60? Sine 60 degrees is the same thing with the square root of 3/2. Perfect. And what does this represent for 60? This piece in green. Very good. Cosine 60 degrees, which is 1/2. They have to be the same because it's the same measure. So this piece is the same for 30 and for 60, but different trig functions, however. For 30 is sine, but for 60 is cosine. This piece is cosine for 30, but it's sine for 60. And this is what we talk when we say, this is what we refer to, cofunction identities. So based on what we just observed, I'm going to ask you to tell me what does sine 70 degrees equal to? Yes, cosine of? Awesome. Exactly. Because sine 30 equals cosine 60. It's the same measure. Very good. Now I'm going to say tangent 35 degrees. It happens for all pairs, meaning sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. So tangent 35 must equal cotangent 55. Correct. Very good. What about cosine 25 degrees? Yes, but what?
Oh, sine.
Very good. So in general, now we can write the cofunction identities. So I will say sine alpha is the same with cosine 90 degrees minus alpha, or I can write the same thing as cosine pi over 2 minus alpha. Let's say cotangent, just one more. So please give me the identity or the cofunction identity for cotangent. Yes, tangent of? Yes, or if you want, tangent pi over 2 minus alpha, because we know 90 and pi over 2 mean the same thing. Okay, so we're ready to go back to I would like to look at a problem from 6.2 because we have not looked at any word problem from 6.2. I like something like this with determining a distance. I think it's useful. Height of a cloud cover. I think that that's useful. This is the height of a balloon. I think that's interesting. Height of a tower. That's interesting. So please choose. See how trig of the right triangle is applied. So what will you be interested in looking at?
Height of the tower.
Okay, very good. So the height of a tower. So I have to copy the figure.
What number is that?
Oh, I'm sorry, 55 on 450. Okay, we have this distance between the building and the tower as 325 feet. And there is a person apparently somewhere here. Okay, so let's read the problem. A water tower is located 325 feet from a building. From a window in the building, an observer notes that the angle of elevation, so let's talk about that before we read on. So at my height, I'm 5'5". So my eyesight horizontal line is this going this way, right? Towards the left wall for you. What will be the angle of elevation? The angle of elevation is the angle from my eyesight, from my horizontal, where my eyes are, looking up to a point. That's the angle of elevation. So let's say I'm looking to determine that angle between my eyesight, the level of my eyes, and where the ceiling and the wall are connecting. That's the angle of elevation. Now, let's say I want to look at the bottom, let's say at the floor, at the baseboard. That would be the angle of depression between the horizontal and that point. Okay? So this will be the angle of elevation, and this will be the angle of depression. So from a window, okay. Angle of elevation to the top of the tower is 39 degrees. And the angle of depression to the bottom of the tower is 25. How tall is the tower? How high is the window? So there are two questions here. They're asking us to determine this. I'm going to call it X. And they're also asking us to determine this. I don't want to call it Y. Let's say I'm going to call it A. I can call it Y. It doesn't matter really. Okay. So the idea is this. And I do have this measure. This is given to us as 325. Any suggestions here on how to determine that height? Any ideas for me? Yes?
Sine of 325. Sine of 39 plus the sine of 25. Was X.
As long as I know that this is 1.
Right.
But I don't know that this is 1.
Right. So do we... Okay, so we have a right triangle that's A, and then at 325. Those are two right triangles.
Good.
Are you assuming that, or like do you assume that in the which one?
But look, so I'm looking directly the shortest distance from my eyes to the board. It must be, I'm looking perpendicular. That's the shortest distance, right? When I look up, I can't.
Yeah.
It cannot be the shortest distance. But when I look at the wall, the shortest distance must be perpendicular. Very good question, actually.
We know that that's So sine of 25 is A.
Figure out the other. Right?
So let's stick with this
Okay.
for now.
Right, what I'm saying. If you know the fixed, now you know the other angle.
I have this piece, right?
Yeah.
And I have this angle.
Yes.
Is there any way I could determine this piece?
Yes.
Which trig function will help me? Nothing that involves the hypotenuse. I don't know anything about it. So no trig function that involves the hypotenuse can help me here.
Yes, but say that again. You know this piece.
I know this piece. We're given 325.
Yes.
I know this angle, and I want to determine this piece. Which trig function will I apply here? Of course.
Yeah.
Remember, tangent is the
Because
key.
you have the cosine, which is 325.
So I'm going to call this x1, and I'm going to call this x2, and I'm going to say that x is x1 plus x2. And in this triangle, I'm going to say, write that tangent 39 degrees equals
X1 over 325.
very good. And this is a proportion. I want from here, I want to solve for x1. What do I do to solve for x1?
Cross multiply.
Correct. So x1 is 325 multiplied by tangent 39. Leave it alone. Please do not write 325 behind 39 because you may think that you have to multiply 325 by 39 degrees and then apply tangent to it. So this is tangent and trig functions are really iffy when it comes to writing anything behind them. It's like the square root. I will not write the square root of 3 times x. I will write x times the square root of 3 because I may be tempted, who knows what, to extend the square root on top of x. And that would be a terrible mistake. So normally, trig function should be at the very end. Good. In the same way, you will give me x2.
It's tangent, or 325 times tangent 25.
Everything is the same, correct? I still have the opposite over the adjacent. And now I can put these in the relationship I'm interested in determining, right? So I have this piece now, it's here. I have this piece, it's here. So x equals 325 tangent 39 degrees plus 20 tangent 25 degrees. Remember, you cannot touch these. You cannot do anything to them. I only factored out 325. So let's go to, I thought I was prepared, I'm not. Make sure that your calculator is in degree mode. So go to mode and change it to degree because I am going to put in degrees. And then second and quit. And write 325 in parentheses. Tangent is right here, 39, close the parenthesis, plus tangent 25, close the parenthesis and close the outside parenthesis. And I got the height of the tower. How high is it? How tall is it?
414.73 feet.
414.73 feet. Please keep in mind, tangent is an extremely useful function. All of them are, but tangent is. Any questions here? Is this okay? Good. Now, we are also asked to determine A. Well, do I?
So that's just tangent 25.
That's it. So no, you see the height is this piece.
Yeah. Right.
But 325,
Oh, yeah.
right?
Mm-hmm.
So this is our x2. It's the same thing with the x2. A and x2 are the same. But now I have to find, so A and x2, I have to approximate it. Just 325 times tangent 25. 25 times tangent 25. 151.55 feet. Any questions for me? Any questions? Okay, let's also look at height of a balloon. A hot air balloon is floating above a straight road. To estimate their height above the ground, the balloonists simultaneously measure the angle of depression to two consecutive mileposts. Keep in mind, mileposts, consecutive mileposts, are at what distance from each other? Exactly 1 mile. Okay, on the road on the same side of the balloon. The angles of depression are found to be 20 degrees and 22 degrees. How high is the balloon? By the same side, meaning they were not between the mileposts. The mileposts were on the same side. That's what it means. So let's look at 58. Same page, 450. So the balloon is not here measuring these. That's not the situation, right? So the balloon is here. This is the road, and these are the mileposts. Well, let's say A and B, and this distance is 1 mile. And of course, I have to draw the horizontal. This is the first angle of depression, and this is the second angle of depression. So they said the angle of depression to the first one. So they are 20 and 22. Which one is 20 and which one is 22? This is very important. So I'm going to call this C. With CA or with CB is 20?
CB is from the
Very good.
CB.
Very good. The larger has to be 22. The smaller has to be 20. Very good. That's very important. So they're asking us to determine the height. Let's read the problem one more time. Make sure we put in everything and everything is correct. Hot air balloon is floating above a straight road. To estimate their height above the ground, the balloonists simultaneously measure the angle of depression to two consecutive mileposts on the road on the same side of the balloon. The angles of depression are found to be 20 and 22 respectively. How high is the balloon? Okay. So the same idea. I have to look at a right triangle. Basically two. Here's one. And here's the other. And of course, I can determine this angle easily. And I can determine this angle easily. And then I'm in business. Can anyone give us the angle CAT? CAT. And how you got it?
90 minus 22.
So 90 minus 22 is this.
Yeah.
This angle. But I want this one.
Oh,
So then minus.
yeah.
So what should this be? Exactly. How do I know that without any calculations? Anytime we have two parallel lines crossed, then this angle must equal this angle.
Right.
Alternate interior angles. So that's how I knew that this is 22 and this must be 22. How much is this? That's it. So again, I have two triangles. And I'm trying to determine one leg that happens to be a piece, same piece, identical piece in two different triangles. So in triangle ATC and triangle BTC, I cannot disregard this because I have two variables here. I don't know this. I have no idea what this is. And I have no idea what this is. I only have this angle, and this angle, but I don't have this measure, and I don't have any of the sides of the triangle. So I have to make use of this triangle as well as of this triangle. I don't have this, I don't have this, I don't have this. But I do have this. Because I have this, what can I write? I can call this piece and I can call this piece, and I know something about x2 and x1. I use the relationship that I can write immediately.
When x2 equals minus 1 mile equals x1.
It's 1 plus that. So the difference, x2 minus x1, must equal 1 mile. Do we agree with that? Or if you want to say x2 equals 1 plus x1. Good. So maybe somehow I can get an expression for x2 that involves h. And maybe somehow I hope I can get an expression for x1 that involves h. So any suggestions moving forward? In the small triangle, keep in mind tangent is a very, very powerful function. What can you write in the small triangle in ATC?
Tangent 22 equals h over x1.
Over x1. Very good. I want to solve this for x1. Now, be very careful. Now I have to cross multiply. And write x1 times tangent 22 degrees equals h times 1. I have to solve for x1. So therefore x1 will be? Very good. Can you quickly, with no other calculations, give us x2? That's it. We won't do anything special this time. It's the same thing. So now I'm going to plug them in. And I finally have one equation with how many variables? After I plug them in. Exactly. Exactly. So I will replace h over tangent 20 degrees minus h over tangent 22 degrees is 1. What are the two key words in math?
Smack your own.
Thank you very much. What will you think I'm going to do now? Which one? Simplify doesn't work. There is nothing I can simplify. My hands are tied when it comes to simplifying. So what can it be? What? The only one that I can factor. What do I have left in parentheses? Exactly. Minus? That's it. Don't bother to find the least common denominator. This is not useful here. So h will be, this is just a number. How will I get h?
Divide by
Exactly. Exactly. I just have to be careful how I put in the graphing calculator, but I'm not going to do anything else to it by hand. Oh no. So, 1 divided by, in parentheses, 1 divided by tangent 20. Close the parenthesis. Minus 1 divided by tangent 22. Close the parenthesis and close the parenthesis for the denominator. Remember, parentheses, a set of parentheses must be around the denominator. We know that from rational functions, right? We always plug them in with parentheses around the top and parentheses around the bottom, correct? Okay, so I plug in, I press enter, and I get 3.67. So measurement unit. What is the measurement unit for 3.67? How high is the balloon? Up in the air.
miles.
Yes. Any questions? Any questions for me here?